Welcome to Lesson 41, Part 1 of our interactive notes. So Lesson 41, Subtracting Mixed Numbers Using Equivalent Fractions, pages 29 and 30. Okay, so our content objective for 4th grade NF Numbers and Operations Fractions, B.3c. I can subtract mixed numbers with like denominators. 4.OA Operations and Algebraic Thinking, A.3. I can determine how reasonable my answers to subtraction problems are by using estimation. Language objective. I can use vocabulary related to fractions in addition to communicate how to subtract mixed numbers. Social objective. I can work with others to create models to prove the solution to the subtraction of mixed numbers. So here we're going to look at estimation when it comes to subtraction. It's similar to adding mixed numbers. First we need to find the nearest whole number. So what is that fraction closest to? Is it closer to 1 up, the whole number up, or 0, the whole number down? So which whole number is it closest to? Use mental math to subtract the two whole numbers. Alright. So first let's look at, there are two different things that we're looking at here with subtracting with equivalent fractions. We're going to be looking at improper fractions mainly. So here's our problem. We have two whole units, and I only need to take away 2/3 of a unit. So that means I need to cut into 3 pieces each whole, and right now they're not cut. So first thing I'm going to do is I'm going to cut up those 2 into thirds. So I cut this one into 3 pieces and this one into 3 pieces. And I have a total of 1, 2, 3, 4, 5, 6 thirds. So a way of looking at this to get that equivalent fraction is every whole number can be written over a 1. Because I have 2 of the whole thing. And then if I multiply each of these by 3 and cut them into 3 pieces each, then I get the 6 thirds. So if you don't have a model, that's what this multiplying is doing. It's taking the 2 whole units and cutting everything into 3 pieces. So I end up with 6, and instead of it being the whole thing, they're now thirds. So now that I have 6 thirds, there's my equivalent fraction. Now I can take away 2. 1, 2, and I end up with 4 thirds. Well, when I have those 2 thirds taken away, I want to be able to rewrite it as a mixed number. The 4 thirds is actually correct. That is a correct answer. But for somebody that may need to use this for something where they need to know the mixed number, you've got to be able to put it in that form as well. So how many 3's can I get out of 4? I could get 1 3 out of 4. 1 times 3 is 3. And then I have a remainder of 1. So I have 1 whole, and I have 1 third. So here's my whole number, and then my remainder over my divisor. So I have 1 whole still, and 1 third. Or I have 4 thirds. Okay. Now I'm going to look at my subtracting when they both have fractions. So this is if I have just a whole number, Here I have a mixed number that I'm subtracting from. I need to change both of these into the improper fractions if I'm using my equivalent fractions. In the next lesson, I will show you another way you could do this. So first, I take my 3 1/3. There's my 3 whole and my 1/3. And I need to cut it up, each of these, into 3 pieces. So the 3 times 3 equals 9. So I get 9 pieces here. And then I take the 9 and I add it to the 1. I get a total of 10 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 thirds. Because this just tells me the size pieces, and a third is that one whole is cut into 3 pieces. Each of these is cut into 3 pieces, or thirds. I do need to change this one into an improper fraction, so it's 1 times 3. So I need to take away those 3 plus the 2 more that I already have. So I really need to take away 5 thirds. So 3 1/3 can be written as 10 thirds as its improper fraction. 1 2/3 can be written as 5 thirds. Well, 10 thirds take away 5 thirds. 1, 2, 3, 4, 5. Leaves 1, 2, 3, 4, 5. 10 take away 5 is 5 thirds. They're still cut into thirds. But what is 5 thirds? 1, 2, 3, 4, 5. So it's 5 taken away. What is 5 thirds written as an improper fraction? How many 3's can I get out of a 5? I can get one group of 3 out of 5, because 1 times 3 is 3. And then I have 2 remainder. So I have 1 whole, there's my 1 whole, and my remainder over my divisor, and 2 thirds. 1 whole and 2 thirds, or 5 thirds. They mean the same thing, they're equivalent. It just depends on which one you need to use more. Sometimes in higher math this is more useful, but in practical uses this one's more useful. Okay, so now we're going to practice with our estimation also. So 4 is a whole number. So we're done. We've got 4 for that. But 3/5, what is that approximately? What is that closest to? Well, that is closest to, half would be 2 1/2. That's half of 5. So it's more than a half. So that means it's closer to 1. So 4 take away 1 is 3. The estimate is 3. Okay. So here, now I'm going to go through the steps. I have 4 take away 3/5. So now I need to take this 4 and I need to cut them all into fifths. I need to cut each one of these. And if yours is not perfect, that is okay. 1, 2, 3, 4, 5. Okay, so how many fifths are in 4? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. we have 20 fifths so 4 can be written as, now if you didn't have a model, I have 4 whole units and I'm cutting each into 5 pieces. I get 20 fifths. 4 is equal to 20 fifths because 20 divided by 5 is 4. This fraction bar right here can be seen as division. 20 divided into 5 groups and you get 4 whole. Okay, now that I have it subtracted, I could take away 1, 2, 3. 20, take away 3, more on the floor, go next door, regroup 10 more. 10 take away 3 is 7, and 1. We get 17 fifths, and you could count that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 fifths. But what is that as a mixed number? How many 5s can you get out of 17? I can get 3 5s because 3 times 5 is 15 and a remainder of 2. So there's 3 whole and I have 1, 2, 3 whole and a remainder of 2 over 5 or 2 fifths. Is that close to my estimation of 3? Yes. So that is reasonable. So my answer is 3 and 2 fifths. Okay, now we're going to deal with our 2 mixed numbers. First we have to estimate. So 5 and 2 6 is approximately, well, half of 6 is 3. So 3 6 would be halfway. That means this is less than half and it is closer to just being 5. 1 and 3 6. Well, 3 6 is exactly half, and when we're exactly at half, we tend to go up. So this is closer to being 2. So 5 take away 2 is 3. The estimate is 3. So here I have 1, 2, 3, 4, 5, and 2 6. And I need to cut them all up into 6. That 5 times 2 equals 10, and 10 plus the 2, I'm sorry, 5 times 6 is 30. I need to cut it into 6, not the numerator, the denominator. 5 times 6, because I got to cut each of these into 6 pieces, is 30. So if I take all of these and cut them into 6 pieces, so you can cut them into thirds and then each of those in half, and that's an easier way to get 6. I have 6, 12, 18, 24, 30, plus the 2 I already have gives me 32. So I get 32 6. And I need to take away, well, 1 times 6 is 6, and 6 plus 3 is 9. So 1 times 6 plus 3. I need to take away 9 sixths. So 1, 2, 3, 4, 5, 6, 7, 8, 9/6. 32, take away 9. I have more on the floor. Go next door, regroup 10 more. 12 take away 9 is 3 and 2. So I should have 23/6 left over. 6, 12, 18, 19, 20, 21, 22, 23. So that is my answer as an improper fraction. That is correct. I can leave it that way. But I should be able to put it into mixed numbers because that could be more useful. So we got to be able to do both. So let's see, 3 times 6 is 18. More on the floor, go next door, regroup 10 more. 13 take away 8 is 5. Okay, I can't take out any more, so that's my remainder. So I have 3 whole rectangles, 1, 2, 3, and 5, remainder over divisor, 5, 6. So 3 whole and 5, 6. Is that close to 3? It's a little closer to 4. But this one went down and this one went up. So that makes the difference a little bit off, but it is pretty close to 3. So that answer is reasonable. All right, now let's do a little bit more practice with this in part 2.